All right, good afternoon, everybody, and welcome to Water Wednesday. My name is Kathy Schultz, and I am the Water Education Specialist with the California Department of Water Resources. The mission of the California Department of Water Resources is to sustainably manage the water resources of California in cooperation with other agencies to benefit the state's people and protect, restore, and enhance the natural and human environments. This month for Water Wednesdays, we are talking about watersheds, what they are, why they're important, and some of the risks that they face. If you missed last week's introduction to watersheds presentation, you can find it as well as all of our past episodes on our DWR YouTube channel. This week, we are joined by Daniel Wisherup. Daniel is a senior environmental scientist specialist, and he will be talking about the impact of wildfires on watersheds, particularly on water quality. As if you've lived here or studied a little bit about California's natural history, you know that many of our watersheds are adapted to fire, or many of our ecosystems, excuse me, are adapted to fire. And in some cases, they even depend on fire. And if you've lived here for any amount of time or followed the news, you know that in recent years, we've experienced a greater number of fires, many of which are larger and hotter than what traditionally occurred in the past. And these fires not only impact people and the animals and the forests or the areas where they burn, but they also have impacts on our waterways. And in response to this, DWR scientists like Daniel are monitoring and studying the impacts of fire. Before I turn things over to Daniel, I'm just going to go over a few logistics for those who are joining us on Zoom for the first time. We have asked you to join with your microphones and video cameras off. This just helps us remove any distractions, background noise, things like that, so everybody can focus on Daniel and his presentation. But we do really want to hear from you. So if you have any questions for Daniel, either during his presentation or after he finishes up, all you have to do is take your cursor and go down to the bottom of your screen, and you'll see a little word bubble that says chat underneath it, and you can put those questions in there. You want to be sure and send them to me because I'm going to be the one reading them and asking them of Daniel. So just go ahead and send any questions you have, and we will get to as many of them as we can. We also have the option for captions. We have a live captioner with us. And to turn on the captions, you just, again, go down to the bottom of your screen, move to the right, and click on the button that says CC for closed captions. Lastly, one more thing before I do turn this over. I do want to let everybody who's joining us today know that Daniel's presentation does include some images from recent fires, including but not limited to the Camp Fire. And we know that these were traumatic events for many people. And so we just wanted to let you know in advance that there will be photos from the fires as Daniel talks about what happened, the impact on the watershed, and the work that he is doing. So with that, I would like to turn things over to our today's guest speaker, Daniel Wisherup. There you are. Hey, Daniel.
Hello. Okay, so I'll go ahead and pull this up. All right. Look good?
Looks great.
Okay. All right. So as Kathy mentioned, my name is Daniel Wisherup. I am a senior environmental scientist with Department of Water Resources, and I work primarily on water quality projects. This can cover a lot of different topics all throughout the state, but the issue of wildfire impacts to watersheds is one that I have become more and more involved in over the past few years. And so, like she said, if you had joined us last week, you would have heard what a watershed is. But for those who weren't there, a watershed is basically a basin in which all water flows downhill to a common point. So when something disrupts a watershed like a wildfire, then local impacts higher in the watershed can have effects on those downstream. And it's those impacts that I'll be discussing today, along with work done by DWR as well as other agencies to respond to and recover from these fires. So, can you think of some ways in which a wildfire might impact a watershed? Uh, Probably the most visible and obvious impact is the burning of vegetation. And this can include everything from the smallest tiny grasses to the largest trees. And it can leave the watershed landscape looking barren, like you see in this picture here. What many people don't know is that wildfires can also burn the soil. Because wildfires burn so hot, they can actually close the pores between soil particles and can change the chemical structure, resulting in a layer of soil that repels water. And in scientific terms, something that repels water is referred to as hydrophobic. So in this case, rather than rainfall soaking into the soil like you might see if you were to pour water into your garden, uh, in this case, rainfall runs off the surface, more like if you were to pour water onto a raincoat. So the lack of vegetation and the increase in hydrophobic soils creates a condition where more of the rainfall that falls in the watershed flows downhill rather than being retained in the soil or in the upper parts of the watershed. And this water that flows over land after rainfall events is called runoff. And while a fire might burn for more than a month before it's put out, the effects of runoff from burned area watersheds can have impacts for several years. And these impacts from the burned area runoff can take several different forms. All of the excess water flowing downhill can overwhelm traditional flood control measures and can result in an increased chance of flash flooding. This excess water can also carry with it debris and mud from the burned areas, which can damage downstream structures. And lastly, because of the damage done in the watershed to the forest and to buildings, the runoff can carry with it contamination, which can either be natural or man-made, and this can harm downstream watersheds. So this contamination can take several forms as well and can come from several different sources. The largest potential contamination is that of increased sediment and soil carried by the runoff. This process is called erosion, and it is a natural process. However, in areas affected by wildfire, erosion can be very high and can carry a lot of sediment and soil into downstream waters, which can cloud the water and or fill in creeks and rivers with silt or mud. And the sediment and soil also carries with it heavy metals and minerals, which do occur naturally. However, the additional runoff can increase their concentrations high above what's natural. The additional runoff can also carry with it organic matter. This can include plant material from the forest floor or compounds dissolved from the soil. These two can cloud the water, and they can also change the natural chemistry in downstream waters. They also have another impact in that it can disrupt the water disinfection process. In this case, the chemicals used by water treatment plants to make the water safe to drink can actually mix with organic compounds and create harmful disinfection byproducts. The sediment and organic material can also carry with it nutrients. And typically nutrients are a good thing. You know, you need them in your diet to stay healthy. Your plants at home need it to grow big and strong. But in the water, nutrients can also help algae grow, which can result in algae blooms that can be harmful to pets and people who use the water. But wildfires can also cause the release of or even the creation of harmful chemicals that can be carried by the runoff. This can include things as small as litter and debris in the watershed or things as harmful as chemical leaks and damaged industrial equipment. But the end result is the increase in toxic materials being released into the environment. And similarly, biological materials can also be released after a wildfire. This can include human sources, like is shown in the middle picture, that's an open septic system. And it can also come from animal sources, such as runoff from cattle grazing lands or wildlife waste. So these 5 sources of watershed contamination are ones that can commonly be found following any wildfire. But I'd like to focus your attention now to the Feather River watershed. So this map here shows the watershed boundary in the gray and black line. It also shows wildfire boundaries from 2000 to 2019, shown in red. The map also shows Lake Oroville, which is the lowest point in the watershed and is an important part of DWR's work. As you can see, the fires are common in this area, as Kathy had mentioned. They are important in the ecosystem. And in the Feather River watershed, we've had everything from very small fires to some rather large ones. And I'd like to point to one of those larger fires, which was the Camp Fire. This fire burned starting in November of 2018. It was covered very extensively in local and national news. Even though it lasted just 17 days, it was one of the largest fires at the time, and it is California's deadliest fire, having destroyed the town of Paradise. Because of the large scale of the fire and its devastating impacts, it took a lot of people and agencies to respond to it and recover from it. The first people that might be the most obvious would be the firefighters, who risked their lives to contain the fire and minimize the risk to life and property. Similarly, right at the same time, you had local governments and disaster relief organizations working to provide support to people who have been displaced by the fire. And this support has continued long after the fire had ended. Also, once the fire ended, work began on cleaning up the areas that had been damaged. This included crews who went out often wearing safety gear in order to clean up toxic material from the burned areas before it could run off into the watershed. There were other groups who took a broader look at the fire and used satellite imagery and on-the-ground assessments to determine other areas that might have higher risks once winter came and we started seeing runoff from the burned area. There were groups who used this data and went out in the field and spent tireless days installing preventative measures to reduce the amount of runoff and to help protect the watershed. And lastly, there's groups like mine that go out and do research on what runoff does occur and determine if there is any potential for harm to the watershed. In the case of the Camp Fire, there were 2 groups who did these impact studies. My group focused on the Feather River watershed and runoff to Lake Oroville, and a group from the Central Valley Regional Water Quality Control Board focused on the runoff from the other half of the fire, including the town of Paradise, and that impact to the Butte Creek watershed. So for our study, we used comparisons to help determine the impact from the fire. The first set of comparisons we used were looking at changes across locations, referred to as a spatial comparison. In this case, we used samples from the river upstream of the fire compared to samples from the river downstream in the fire. The second comparison type we used was across time, referred to as a temporal comparison. In this case, we used samples from a site in Lake Oroville that has been sampled for many decades. And this allowed us to look at the impacts after the fire compared to normal conditions in the lake. And it includes the influence from other rivers flowing into the lake that weren't affected by this fire. So what did we find? Well, we found a lot of results that we had expected to find. We saw increases in organic matter, metals, nutrients, as well as sediment. But why do I say some here? Because we also had unexpected results, which included decreases for some organic matter, metals, and nutrients. Generally, what we found were increases for compounds that are commonly found in or bound to soils in this area. And for compounds not typically found in the soil, we either saw decreases or no change in concentration. And also on the positive side, we didn't see any significant occurrence or concentrations of chemicals downstream of the fire. We also found a trend that's common in stormwater sampling, whereby the initial samples soon after the first rainfall is high in concentration, which then decreases over time as more rain falls and the watershed flushes out. This is referred to as the first flush effect. And the last result we saw, and possibly most encouraging, was a return to normal conditions. For many compounds, we saw an increase in concentration after the fire, which is shown by the yellow bar in these graphs. However, as the winter went along and into the next summer, the concentration of contaminants in the burned area runoff diminished, and water from the unaffected parts of the watershed flowed into the lake and helped to dilute the higher concentration waters from the fire. And this is especially encouraging considering what we saw in the 2020 fire season. So last year, another fire started in the Feather River watershed. This fire was North Complex Fire, and it burned an even larger portion of the watershed upstream of the lake, including areas around two of the rivers that had not been affected by the Camp Fire. But because of our experience in responding to the Camp Fire and what we learned in that study, department has been better able to respond to this fire, and we're better prepared in responding to future fires in this and other DWR watersheds. Thank you.
All right, thank you, Daniel.
Mhm.
So we've had a number of questions come in. So if you want to stop sharing your screen, we'll go ahead and start with the questions.
Okay.
Awesome. All right. Where did that chat box go? All right. So going back to the very beginning of your presentation, you mentioned that the wildfire can burn the soil. Does this happen with all wildfires or just the really hot ones or just in really hot spots?
It can happen for any wildfire, but it is most pronounced and happens the most in the highest temperature areas.
Mhm.
So really, the hotter the fire is in any particular area, the more potential it has to burn the soil. And so with the Camp Fire, we saw certain areas that had very high burn temperatures
Mhm.
and other areas that had much lower temperatures, and the soil likely remained similar in those low burn areas.
And are you able to like pinpoint and see if there's any differences in the water quality and the downstream areas from the burn soil areas and the non-burn soil areas? Are you able to be that precise, or is that too specific?
We were not, for the Camp Fire, able
Mhm.
to get that specific. A lot of the Feather River watershed, even low down close to the lake, is very hard to access
Mhm.
either by vehicle or by foot.
It's very steep out
So
there, right?
very steep, very remote.
Mhm.
So the locations that we were able to sample were pretty much the limit of where we were able to get to.
Are you looking at any ways that the added sediment or soil or runoff affects fish or wildlife, or are you really looking at the broad water quality?
Our approach is sort of the broad water quality. We do have several beneficial uses of the lake that we factor into our decisions for what to sample for. Our role is really to collect the data
Mhm.
and make it available in the future for the department or other groups who may wish to analyze effects from this fire
Mhm.
to the overall health of the watershed and the lake. So we don't necessarily draw any direct results as it may affect fish in the lake. But that is something that we think about and we're aware of when we plan these types of studies.
Okay. Do you work with different agencies like Fish and Wildlife on these, or do they have their own studies going on?
Fish and Wildlife, we do work with them. They've been a part of the watershed response teams that
Mhm.
form after these fires and help determine what sort of analysis and monitoring should be done. And we make our data available to them and any other agency who's involved. Um, for the campfire, I don't think that they went out and collected any of their own samples.
Mhm.
But I do know for other fires, wildlife agencies do get heavily involved.
All right. Okay, questions are coming in fast. We have a question about drinking water. Do you find are you sampling for issues with drinking water, or have you found any?
Yeah, so we sample the raw water either coming into the lake
Mhm.
or in the lake itself. We don't collect samples of the treated water. Um, so that's sort of our approach in providing water to water treatment agencies. And
Mhm.
we try to provide them data about the raw water quality so that they can be uh, prepared to respond to any issues.
Mhm.
Things like sediment can make the water treatment process harder. As I mentioned in the presentation, the organic material can cause issues with the disinfection process, which would require further steps from these agencies in order to properly treat the water.
Mhm.
So we did see increases in both of those. Um, and we make that data available um, to those groups.
So the local water agencies that are receiving the water downstream and will be delivering it to people, you sort of let them know what's coming at them.
Mhm.
We have a question about debris flows or mudslides. I don't know if this is something you would know about or not, but do you know if there's maps showing where these occur or have
Yes,
occurred?
well, yeah. So before the fire, I had mentioned those agencies that take the broader look at the fire and and use the satellite imagery. One of the things that they produce are maps with debris flow potentials for different areas of the watershed.
Mhm.
Those are prediction maps, and they do make those available beforehand, which can help in the planning process.
Mhm.
Excuse me. And then there are also agencies that would map where specific landslides or mudslides do happen.
Mhm.
If I recall correctly, though, from the campfire, I don't think we had any significant landslide or mudslide events from that. So I haven't seen any maps for that particular fire.
Okay. Well, that's something good, right? Um, so we have a question from somebody who noted the promising results of no long-term impacts in Lake Oroville. Um, are there any potential short-term impacts that we're concerned about, you're concerned about before the lake does return to normal?
Yes, there is, the potential for that short-term increase to have had
Mhm.
um, impacts at that time, and also impacts closer to the fire itself, where there's less mixing in those upper arms of the
Mhm.
lake from the unburned portions of the watershed. Uh, the potential for algae blooms increased in that area. We did see one algae bloom downstream of the fire
Mhm.
in an area that we typically don't see them, although it's not beyond what could naturally occur. Um, so it's hard to determine if that was directly related to the fire.
Mhm.
But some of those localized short-term impacts um, could have happened. It doesn't look like we've had anything long-term and nothing significant at the time that required, further response from the department to
Mhm.
mediate.
Got it. Okay. Um, Again, I don't know if this is something that you're looking at because you're really looking at water quality, but did you notice or do you know of any impacts on the base flow of the river from increased runoff and decreased infiltration?
Yeah, so actually, increased base flow is something that has been researched a lot with fires, and it is, commonly known that that can occur.
Mhm.
The winter right after the fire was a pretty wet winter, so there were some pretty high flows coming down at that time. Um, so I haven't seen any comparison of actual flow data, done by any of the engineers showing, um, any sort of long-term impact to base flow. The next winter, last winter was a lower,
Right.
uh, drier winter, so we actually saw a lot less rainfall and a lot less flow that year. But I haven't seen any of the models that would show exactly what is attributable to the fire.
Sounds like there's a lot of factors going in to this, just like how much precipitation we get in a year, the impact of the fire. Like you're saying, it wasn't clear if the algae blooms were directly related, or if we're just seeing more algae blooms with like warming temperatures. It sounds like it's a kind of a challenging job to figure out what's going on out there.
Yeah, there's a lot of variables in the natural environment, so it can be difficult.
Mhm. Um, One last question for you. How did you end up in a career in water quality testing? Did
Yeah,
you go to
so
school for this or?
for me, it started in college,
Mhm,
getting my degree in environmental science and internship slash research project
mhm.
that I had as part of that, where we were looking at stormwater runoff in Tucson, Arizona,
Oh,
which is heavily monsoon influenced. So they get majority of their rain in just a few week period, and flows get very high very fast. So we were looking at runoff contamination in those events, and so I really enjoyed that. Pursued that sort of field more in school, and after getting out, sort of circled my way back around into the water quality field, and ended up doing similar work in regards to this project, and it's
okay.
been really great.
All right. So you've been looking at the impacts on water for quite a while.
Yeah.
Well, unfortunately, there's still more questions in the chat box, but we are out of time. Um, but I want to say thank you, Daniel, for joining us today. This was a really, really fascinating presentation. And I want to thank everybody in the audience who came out and joined us today and put in some really great questions. And I apologize if I did not have time to get to them all. I do want to encourage you to join us again next week. We'll be back with Cassandra Ivinson, and she will be talking more about watershed protection, some of the laws that guide it and influence some of the work that Daniel's doing, as well as how DWR collaborates with other agencies on keeping our watersheds healthy. In the meantime, if you're interested in learning more about the Department of Water Resources, I invite you to visit our webpage, water.ca.gov. We also have a number of educational resources available at water.ca.gov/education. And if you do live in a fire-prone area, um, to learn more about wildfire and how to prepare for it, how to respond, or how to know when one is near and how to respond to it, we encourage you to visit www.readyforwildfire.org. That's put out by CAL FIRE as well as a number of other state and federal agencies, because as we've seen, these fires can have a pretty big impact. To also stay abreast of what DWR is doing and find out when more Water Wednesdays are going to be held, you can always follow us on social media. DWR is on Facebook, we're on Twitter, we're on Instagram, and we are also on LinkedIn, where we will post jobs if there's an opportunity to do the kind of work Daniel's doing. Might be able to find that on LinkedIn. So thank you again, everybody, for joining us. Thank you again very much to Daniel, and we look forward to seeing you next week. Bye-bye.